So in terms of functions, when an inverse relation is found, the x values of the original relation are the y values of the inverse relation, and the y values of the original relation are the x values of the inverse relation. If a point 3, negative 7 lies on the original relation, then point negative 7, 3 lies on the inverse relation. The x and y values are interchanged. So what we want to do here is, for this next example, is take f of x equals x squared minus 4. I want to graph it, state the domain and range, and then we want to find the equation of the inverse relation and graph the inverse relation and state the domain and range of the inverse. Okay, so what kind of graph is that? What kind of shape? And how has that been transformed? And see if... Okay, so we're going to graph this. Okay, so there will be the origin. Okay, so then we just have to graph this function. Okay, so that's f of x equals x squared minus 4. Okay, state the domain and range of f of x. Okay, pause the video and please work on that. Parabolas with no restriction have the x values are all elements of all real numbers. For the domain and for the range, okay. Then we move along to the steps for finding the inverse. So first what we're going to do is we're going to rewrite f of x equals as y equals. Then we're going to interchange the x and y. And then we're going to solve for y. Okay, so if f of x equals x squared minus 4, then we'll write that as y equals x squared minus 4. Then we'll interchange the x and y just as it is, so x equals y squared minus 4, and then we'll solve for y. So we'll add 4 to both sides, and then we'll take the square root of both sides. So we get y equals plus or minus x plus 4. Okay, and then on the next page that you have, we've got the grid, and you just need to graph this function. And I know the grid's very, very small, but we'll take a look at graphing this. So there's the vertex, and we basically just take the points of the original function that you had before here, and because we're interchanging x and y, we're just going to interchange x and y also. So a vertex of 0, negative 4 will then be negative 4, 0. Points of 1, negative 3 and negative 1, negative 3 will be negative 3, 1 and negative 3, negative 1, etc. So we just interchange the x and y values also. So we're going to have 1, negative 3, negative 3, negative 1, negative 3, positive 1, and then we're going to have 0 and 2, and 0 and negative 2, And then the other points are 3, 5, and negative 3, 5, so it'll be 5, 3, and 5, negative 3. Okay, and then we just graph that. And then we'll do the domain again. Now look at the domain here. What's the domain of this function? Please pause the video and look at that domain. And looking at that range. Okay, now compare the domain of this transform function, or the inverse function, with the domain of the original function, and then compare the range of the inverse function with the original. But actually, what might even be better is if you compare the domain of the original with the range of the inverse function, and the range of the original with the domain of the inverse function. Remember that the x and y values in our steps here, the x and y values are interchanged, therefore the x and y's, or the domain and range, will also be interchanged. Okay? And so take a look at this. Is that a function? Well, by vertical line test, we could see that there are more than one y values for any x value. So this, as it is not a function. What could we do to the range, in this case, to make it a function? I mean, the domain, we can't really restrict that to make it a function, but we could restrict this. So we could restrict the range of the inverse function, and we could say that that is y is an element of all real numbers such that y is greater than or equal to 0. Or we could say y is an element of all real numbers such that y is less than or equal to 0. Now the other thing we could do is we could, not by restricting the range of the inverse function, we could actually restrict the domain of the original function in the same manner. And that would then give us just one branch, or one arm, of this inverse parabola, or the square root function basically, and then that would be a function. Okay? Alright, so now let's take a look here at some of the key ideas of inverse relations. So f is the name of the original relation. F inverse is the name of the inverse relation. That makes sense. F inverse of x represents the expression for calculating the value of f inverse. If AB is an element of the original function, then BA is an element of the inverse function, or sorry, inverse relation. And the domain of f is the range, as we just saw a couple minutes ago, of the inverse relation, and the range of f is the domain of the inverse relation. The graph of y equals f inverse of x is the reflection of y equals f of x in the line y equals x, because all of the x and y values are inverted, or sorry, interchanged. Okay, so come on back to part 2 of, or part 3, depending on how I've done this,